Yeah, how to do this. So we have this, and I want to write it in this form, I think. Um, we try doing this again, but the from alpha is not helping here. If I just to simplify it, it doesn't make it something like that. My best bet was so far a Taylor series in beta. I mean, at least then you expect this constant plus beta times something plus beta squared times something, etc. Which then gives me kappa. And then I can divide out the beta factor here. So I want to redo the Taylor series here. Let me see. I think maybe can you simplify Taylor series? Taylor series, comma, beta. Let's see how ChatGPT did it. Look at some point here. Yeah. All of that has to be between phrases. So it's actually. I'll show it when I'm done, but I have to. Look at both screens at the moment at the same time because we're having this. No, this. I want to type that in here. Well, that is something divided by beta. And then here I get 2c plus beta times w0. I better use a star here, otherwise alpha doesn't understand that I mean a multiplication. Sometimes at least. Minus the square root of something, meaning being rather. Oops. 2c, again 2 times c then, squared plus 2 times beta times b plus 2 times C times W0. Wolfram Alpha does not understand your quire. No, let's begin with removing the full simplifier from there. How about now? Oh, actually worked. Yeah, well. Do I want to simplify this? For which is necessary that I tell it that C is a real larger than 0. So I can replace those square roots of C by just C, and then this becomes 0, for example. All very annoying that I have no idea how to do that. So could also do is ask for more terms and then make a copy of it. Subscribed. Series line text output. I think this is what I wanted, right? Yeah, let's use more terms then. So I'm gonna copy this. Let's see if we can paste it somewhere. Oh, we have it. And then I want to simplify this. So, oops. Full simplify that whole thing without the last order. And then here we can say C is larger than 0. And I think beta is larger than 0 as well. How does the thing, it's just beta, interesting. Well, at least beta is unequal 0. Well, I don't think it matters much. Actually, it can be negative as well. But I don't think it will change the formula. So. Hey, big chair. No, it's not a game engine. So I copy this, and then we go back to Wolfram, and then it's going to tell me that I have too long query, I bet. At least the last character. No, I think I just didn't copy it. Oh, there it is. Hope you exceeded the maximum number of characters. Got it. Screw you. Stick it where. Okay. What the hell, man? Okay, and what is that bloody limit? I might as well just remove a few terms, I think. She's blah blah blah. Where's my beta? And then it jumps there. Nobody gets why. What is this? Beta to the power 11. I'm not touching my keyboard. Okay, let's do that here then. Blah. Okay, well, for a start, I can make the number of characters less by getting rid of my subscript. So substitute that thing. Escape. With, I don't have a W in here, so I just can make W0 is now W. And you can make a few less terms, I guess. I think I can get rid of a lot of spaces as well. Maybe not that one. I'm actually not sure if we can do that. 2C must be understood, right? Might as well replace B plus 2CW with something. Actually. Though it might be needed to simplify it, I'm not sure. Let me try this. Probably still too much. As expected. Okay, so then we make it a lot less factors. Starting over again. Let's say I cut it off after I can recognize the 2133. Come on, I should be able to do the 33 thing. And then here we get, well, I want to try that one as well. But okay, the rest can be removed. And then I have to go, let's see, this is a one term, and this is a term, and that's a term. And that is a term. That ends in there, I suppose. Now I want to be sure that I copy the ending closing brace. And it's still not there. Oh, it is there, actually. Ah. Oh, don't give me that shit. This is ridiculous. Okay, remove another one. So just keep removing terms until it doesn't complain anymore. As you can see, this is not advertisement for Wolfram Alpha. The last term is a 7. Let's not do these spaces. Oh my god, how long is this going to continue? This only makes me less willing to pay something. Or is it just necessary for them to save resources? Because I'm not paying anything. I mean, necessary, you know. Next you're going to tell me it's going to run out of compute time. Interpreting is... Cry. This is not funny. Okay, what am I missing? Extremely tiresome. We got up till the... Whoa, the 5 term. Really impressive. Okay, I'll do this again. Maybe I made a mistake somewhere. Or maybe it's the spaces that I removed. So I think this was the actual output. So I'm going to do it again. Definitely going to get rid of the subscript, or shall we just first try? Oh, the 5 term is the last one. So I'm going to go to the 5 and then find the end of that, and then the minus something. If I'm not mistaken, plus 21 something, minus 33 something, plus 400 something, 715 something, divided by, and that one ends there, and this one ends really at the comma. So I don't think I did that wrong. So without changing the subscript, hopefully it still works. Nope. Now we do the subscript trick. And now I tried with all those spaces. It's not possible that it doesn't understand what I mean now, right? It's really those spaces that shit. Okay, one more term beats the dust. And then Wolfram Alpha doesn't understand your core. This makes no sense whatsoever. No sense whatsoever. Let's remove these quotes. I would normally not type them, you know. And no. Now we can add back. Comma C. C is larger than 0. That was the whole point. Znanie, yes, I have a Discord. You want an invite? Let me find it. Discord, invite, copy, paste. Now you have, of course, Mathematica on your PC, and you can help me with this because Wolfram Alpha is not helping. Okay, let's see. So this worked. Did it? Yeah, hardly. Hardly. I think I kind of fucked up my Taylor series to begin with. No, it's absolute horror. That's what it is. Looks like I have to do it manually. Unbelievable, but true. Let me think. So I really want to have a few more terms. Let's go for the. Let's see. I'm going to remove this full simplify and assumptions, and then remove these quotes. And then no, I think I can work with W instead of W0. Wolfram Alpha is dead in my eyes. It's so unusable. Unbelievably unusable. Where's my... Okay. I was going to ChatGPT. And then we ask it to... I would have preferred to get it in ASCII art because I have to edit it. Yeah. Okay. Anyway. Odin. No. I'm very limited in my tool usage experience, I'm afraid. I guess with the right tool, this can be done fast. But on the other hand, then you have to spend a year understanding the tool for getting an expert in it, becoming an expert in it. I don't have time for that. I could do this manually fast, but then I have to first get it in my text editor. Cry. I can ask ChatGPT to do something with it. Maybe it will not make a mistake. Let's start with that. Please replace each occurrence of... How the hell do we write it? 2 hours. Occurrence. Or 2 hours. Of square SQRT C squared with just C. It even did a simplify step. Okay, let's see. Romeo plus C beta B plus C squared 16 That's the same stuff, of course. And here we get C, 5C. I guess I did it all correctly, right? The square root just appear here. Yeah, looks good. And then simplification exists of that C was divided away against this C. I did not simplify this for some reason. But okay, so if we divide this by 2c, you get minus b divided by 2c minus w. And there's a w, minus w is 0. So this whole thing is minus b divided by 2c plus beta times and so on. Okay. So this is basically a series in b plus 2cw. And I want to combine it with the rest. I mean, it's, come on, it's it's c squared, right? So what I want is to, I'm going to keep asking it, as long as it doesn't make mistakes, we can work with this. Okay, so now write the first term as minus b divided by 2c, which it is. And divide out, is that the correct term? Let's see. So the beta disappeared, and then we had to make a 2c disappear, right? So like that. Minus 1. Oh, only one beta, yeah, of course. So we still now have a beta left. Times b plus 2cw to the power 3. divided by, and then that bit it becomes 32, I think. 32 c to the power 4. Dead. Stop deploying. I think it is a calling back to the devs. What does he mean? I don't know how to do this. I don't want to be used like a glorified SED. I think it's done. Let me try regenerate. Factoring out. Factoring out. That's what I was looking for. Thank you, ChatGPT. Can I call you Bob? Oh no, it's going to flute me again. Realize that this was indeed equal. Well, I don't know, realize it, but then this is being factored out. Oopsies, I went the wrong way. Shit. Yeah, and that's not good. I think I'll just ignore this question and rephrase it better. What I want is that this becomes twice that. So there must be a 6 here. So I have to factor out 2c beta. Yeah. Yep, then what happens? Then I have to multiply this with 4c squared. So the first factor here becomes 32. and a 4, I think. And this goes to 128. And a 6. And so on. Never admit your mistakes. Just fix them. And make the AI forget you ever made a mistake. Sinayi, yes it is. I'm writing an article for Math Stack Exchange, so you can read that as soon as I'm finished with it. I didn't post it yet, still editing it. Started as a question, but I thought now, well, might as well do everything and then just answer my own question. I'll just abuse Math Stack Exchanges. The way to display my LaTeX formulas. Is this correct? Because it doesn't look correct. No, it is correct, right? Yeah, it is correct. That looks totally correct. I'm going to assume that it did multiply this large number by 2 correctly. And all the betas are... Yeah, okay, I'm happy with this. No. Of course I made another mistake. I think this should be beta to the power 3. Everything must be multiplied with beta squared, actually. In other words, I should have divided by beta here in front of. Okay, edit it again. Vector out, divided by beta. George, like what? Theoretically, theoretically, if you want to be, I don't know, code like me, the 20 years or so, if you're good. I mean, I started when I was 12, so I have lots of experience, like way more than 30 years. But lots of C++, was changed the last decade. So I kind of a large portion of my knowledge of C++ at the very least comes from the last years. So just, and I'm old, so I guess if you start now, then you have the benefit of being young while learning all that new knowledge. And it doesn't really matter that you then skip the time that I spent learning BASIC and Pascal and assembly and stuff like that. It gives a certain insight, I suppose. I know how memory works and how a CPU works. Basically, well, how the old CPUs work too. People who say I don't understand a pointer, they miss something in my eyes. But I doubt it is necessary to code as a teenager for 10 years in order to understand that kind of stuff. It just happened to happen to me because, well, computers just came up at that time. For at least personal computers. Okay, now, did it do this right? I don't think so. Or I made a mistake. No, it's not right. There's a badass squared here. Just click the regenerate thing. Hopefully that now it goes right. Yep, now I did it better. I'm gonna check if it is. Oh, it's definitely better, but if it is correct, it would be even nicer. So I'm going to be divided by 2c, and then it factored out what I asked. 2c divided by beta. And then the first term should be beta squared times b plus 2cw squared divided by 32c to the power 4. And then we get a minus plus, minus plus, minus plus, minus plus, minus plus. And we get those two must be equal. So 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, and so on, all the way correct. And then the thing here is double that one. So that is 3, 6, 4, 8, 5, 10, and so on. Also correct. And it didn't touch that number up there. And it did. Oops. Oh, I'm comparing wrong things. Just times 2 every time. Oh, looks like it is correct. As far as I can check it. So this goes up with a factor of 2. So a factor of 2 goes up with 2 every time. 4, 6, 8, 10. And the bottom thing is going up with a factor of 4, hopefully. 128 divided by 32 is 4. Yes, this one 2040 divided by 128 is 16, unfortunately. Okay. So I'll just ask it to do it. Now, please replace all the denominators in the last vector, the last sum. Sum that is the last vector, whatever. Such that they have the form a times 2c to the power n. For example, 32 times c to the power 4 goes to something 2c to the power 4. That is 2 times that. And 128c to the power 6 goes to 2c to the power 6. So that is then 128 divided by 2 to the power 6 is again 2. And then we get I don't know what was this Taylor series, because this is like close to the Taylor series of some square root expression, but it depends on the denominators. Couldn't get the denominators exactly right, and I think that they are still not right if I do it like this. But yeah, there's nothing else you can do. Well, actually there is. I think working with 2C must be the best approach, certainly for as a beginning step. So here we get 2048 divided by 2 to the power 8 is 8. Don't start with the original expression, asshole. Start with the last expression. Oh, it did that. Very good. Again. 2, 6, 8, 4, 3, 5, 4, 5, 6 divided by 2 to the power 20. 256. That's wrong. This is 256, not 512. You've got to do everything yourself, James. Oh, great. Already at the limit. It's even worse, this one. I think this one was still correct. Let's try to copy this. Haha. No. Tup, 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 tup. No. Oh. Oh. And that's supposed to be minus b divided by 2c. I think the copy did not work really. Plus 2c divided by beta times then we get beta squared not even that can be copied. Let's use another variable here. Just use x. X to the power 2 divided by, and then I must do 32 divided by 2 to the power 4. So that's 2. Minus, and then we have x equals beta times b plus 2 CW. It's actually CW0 divided by 2c. In other words, which is the same as beta times W0. That is obviously W0 plus that. So it is W0 minus minus, which is actually beta times W0 minus W1. Then I get x squared divided by 2 here. Minus x to the power of 3 divided by 128 divided by 2 to the power 6, also 2, plus x to the power 4 times 5, of course. 5 times that divided by 2048 divided by 2 to the power 8. That is 8. Minus 7 x to the power 5 divided by 8192 divided by 2 to the power 10. It's 8. And then we get to the power 6, 7, 8, and so on. 21 x to the power 6 minus 33 x to the power 7 plus 429 x to the power 8 minus 715 times x to the power 9. The rest is not necessary, I think. Hopefully. And then under the 21 we have 65536 divided by 2 to the power 12, 16. Two, 6, 2, 1, 4, 4 divided by 2 to the power 14, also 16. Eight, 3, 8, 8, 6, 0, 8 divided by 2 to the power 16, 128. This should also be 128. Thirty-three, 5544. 32 divided by 2 to the power 18. Yep, also 128. I'm afraid I need more because this is a weird step here. This is a times 2 and then we do times, what the fuck? 128 divided by 16. It's times 8. Times 4, times 2, times 8. There's no pattern yet. Yeah, let's add more. It's all of them then. Maybe even that's not enough. Oh wait, come on, I can do that. Can I not copy this? I can not copy it. I cannot copy it. Unbelievable. Wait, I have it. I have it. 268. I have it here. 268. Done. That. Well, I'm not even sure you can do, yeah, you can. So you have this divided by 2 to the power, what was it? 20. 256. No, it's 256 again. Yeah, this probably also 256. On that, yeah, can I explain what I'm doing in simple terms? Well, yes. Although it's let's see. I can save this file. I am trying to do the following. So I'm looking for a minimum. See a nice example here. No, that's too big. Wait a minute. I'll just start over. Take the first one. Oh yeah, this one is good. So I have, for example, here I have two. I want to find this minimum. Yeah. So this is my function. I want to find the global minimum. So the lowest local minimum that is here. This is done by finding a local minima. So we want to find this local minima first. And I do that by matching parabola. Now imagine that, well, this has another problem, what I'm going to fix. But as you can see here, the parabola that we match is this red one. Don't mind how we got it, because it's kind of weird to plot this parabola while we know that the derivative here is almost zero. It should of course end up there. But the point is that apparently we expect the purple or the graph to be this parabola and therefore have a minimum here. And then we go there and it turns out that it has a value there instead of here. Yeah. And the reason is that there was a minimum before. So we jumped over the actual local minimum here and we missed it. So now the question is, how can I see that we probably missed the minimum? So when is there a minimum between the last point that we were measuring and the new minimum? And I do that as follows. You have here a point where I know the location, that's minus 6, 4, and the derivative, that's this orange arrow here, and the curvature. So that just this one single point is enough to fit a parabola. So that would be this parabola, yeah? So this one. And then we jump there, and then we find that the actual point is way lower, like here, you know. And as you can see, we did not miss a minimum. It just went faster down than what you expect. So it would be pretty good to just continue there. And then we find that it goes to minus infinity. At least this here now is the best fit that goes through P0 and through P1. And that has the same derivative and second derivative in this point. And that then would be a third-degree polynomial. So this curve is a third-degree polynomial that goes through P1 and matches the parabola in P0. I can change everything. So, for example, if I set it here, a bit more space. So if we would measure at this point the same height as that we expect, namely the value of the parabola, then the best third-degree polynomial is equal to the parabola. So we are totally happy if we would find that point. Yeah? And it turns out that if you are a little bit, what you get is a little bit below the vertex, then the minimum of the third degree is on the right, so on this dotted line here. That is the minimum. And obviously this minimum here is equal to the vertex. You shift to the left. Now it's equal to the vertex minimum. And we go up, it shifts even further to that side. So only if we measure something that is higher than the vertex of the parabola, so the expected height, if you just look at the parabola, and then in the end you go there and then you measure that it is higher, then and only then you miss the minimum. Still with me? So what I now am doing is trying to find a formula for where that minimum is. So I know that I can express this height in terms of the height of the parabola vertex plus h. So here's h is 0, and here's h is positive, and here's h is negative. And if h is positive, then we have a minimum between this value here is W0, this value is W1. And then you have a minimum of the third degree polynomial between these 2 points. And I want to have a formula for that. Now I'm writing the article here on MathXchange. So if you're still with me, then I will read it out loud. Make it a bit bigger. So we have the parabola. The parabola is known. We just fitted it. So we know where the vertex is. These are the coordinates of the vertex then for this parabola. And then I state, let W1 be equal to the x-coordinate of the parabola. And then we define a cubic, and we're going to fit the cubic such that it is in value and the first derivative and the second derivative equal to the parabola in W0. But it also goes through the point measured at W1, which is then the distance h above the parabola vertex, or below if h is negative. So we want to find this cubic now that fulfills these equations. Then I can read it. So it can be shown that if h is 0, then the q is equal to the cubic is equal to the parabola. As you just saw when I moved it up, it was sometimes became equal. Which you can show, but you can also trivially understand that from the fact that there's 4 equations and four unknowns, D, E, F, and G. And trivially, if H is 0, then P is a solution of Q, and that must be the only solution. Thus, if H equals 0, then Q has a minimum precisely at W1. And then empirically, what you just showed by graphing it to the computer program, it's easy to see that this minimum moves towards W0 if h is made larger, but never reaches it. After all, W0 is unequal W1, and therefore the derivative, which is equal to the in W0, which is equal to the derivative of the parabola in W0, is unequal 0 because it's 0 in W1. So you can never reach it because then the derivative would be 0 in W0. Maybe I should show this again here. So you have this thing. The point is that if you measure the same thing as the height of the this is the vertex here, and if the P1 is what you measure, that's equal to the vertex, then the cubic equals the parabola. And if you go up, then the minimum is between these 2 points. But no matter how you go, that minimum never reaches this point. Simply because the derivative here is 0 and the derivative here is not 0. So you cannot pass that point. I guess that if you move this up till infinity, then it's going to look like a parabola that just... then you get something like something that bends very sharply here and then goes up. So the minimum approaches it, but it never really reaches it. So it must be exactly between those points. So if h is positive, it's between those two. And moreover, if h is made negative, so if you move it below, then the minimum moves at first to the right, and then at some point it even disappears. As you already saw, I guess. So here we have a minimum, and now we have still a minimum here. But if you go too low, then the minimum disappears. Now we don't have a minimum anymore. So it's kind of a maximum distance, though you still have a minimum, but yeah, I'm not really interested in it anyway. And here there is no minimum at all anymore in the third degree polynomial approximation. So I would like to mathematically prove that, and if possible, I would like to know where the minimum exactly is. So we just fill everything in. So Q at W0 equals, and then the equation of Q with W0 filled in must be equal to P, the parabola at W0. So this is just the equation of the parabola with W0 filled in. And you can do the same for the derivatives and for the second derivative. And then in the end, you must have that Q in W1, which was minus B divided by 2C, must equal to the value of P at W1, which is again just filled in here, plus some H. And if you solve that, you get these equations for the coefficients of the cubic, where alpha appears, where alpha is the cubic of 2C divided by B plus 2CW0. And because this drops out of thin air, I thought let's add the verification, which is way easier than the other way around. So actually deriving it is just painful mathematics. And if you just drop the answer and then work it out, then you can just fill it in and it turns out to be correct. Hence we can write the Q as equal P minus H times alpha times W minus W0 to the power 3. And as you can see, then Q equals P if H equals 0. And now we can take the derivative, because we want to find the minimum of Q. So we must take the derivative and set the derivative equal to 0, and then we can find where that minimum is. So then that way I end up with this formula for the minimum, which is just the solution of a quadratic. The first derivative of the cubic is a quadratic, and you can solve that, and then you get this formula. So there was a lot of 6H alphas in here, so I said let's beta be 6H alpha. Then it becomes a little bit simpler. So now we have the 0 that we're looking for equals this formula. Yep. But I know that at the moment that beta is 0 or goes to 0, then this must be equal to minus B divided by 2C. And that's why I want to write it in this form, so that if beta is 0, then it is that. And if beta is a little bit different, then I can see how it deviates. So for positive H, I'm not even sure what the sign is of alpha, but I'm going to assume that the sign is known. Let me see. Alpha is the third power of this. C is positive. B I'm not sure of, but I can imagine that alpha is positive. Okay, I mean, I don't know. It's actually a bit dubious. W0 can be anything, could be negative. So it doesn't matter if C is much larger or smaller than, C is much smaller than B usually. But yeah, maybe it can go either way, I don't know. Okay, so you have to know how the kappa here looks in order to understand that. Well, no, wait a minute. That was depending on W0, right? We want to, if H is positive, then we want to move the 0 to move towards W0. So if W0 is less than this value, then this is going to become negative when H is positive. And if W0 is on the other side, which is also possible, then it's the other way around. anyway, it's going to be, it will just show that it is the case, what we saw graphically once you find kappa. So that's what I'm doing. That is okay. I now lost what I was doing. It's editing this. So now, oh yeah, then more mathematically. In order to go from here till there, I made a Taylor series of this thing, which turns out to be that constant plus beta times something plus beta squared times something and so on. And I wrote that Taylor series down, so now we have it in this form. If you write x is that, then this is that w. So here we have exactly what we want, except that I am dividing by a beta, but well, there's a beta in here as well, and in x, and there's an x squared. So the whole thing is still beta squared, beta to the power 3, and so on. So now I'm trying to recognize what formula this is then. That's not going to be easy, and I have no idea we'll succeed, but we'll just try it. Okay, so where was I? 2431. So we have minus 4199 times x to the power 11 divided by, and that should be 200 and well, you see 2288 1616 128 128. So yeah, that's going to be 256 here. But let's calculate it. That is going to be wait, this number 107 something. Really? Why can't I not just copy that here? So annoying. Mm, 10737. Do it like this. 107. There it is. Divided by 2 to the power 22. And that's 256. So yay. Next one is 29392 9393. Oh, wait a minute. How's it at 24? I'm not seeing a pattern here. Damn it. Because the easiest way would to get Wolfram Alpha to just generate this here exactly like I type it now. And then we can ask for more terms. And I can get that by starting with what I started with and then removing this term and dividing out that one and typing it in terms of x and then asking for the Taylor series. The only problem is that it is not smart enough to, at least I can't get it to understand that C is larger than 0 and a real. Don't know how to do that. Yep, I need more terms. Where did Wolfram go to? Buried somewhere here. So we have this. No, this is not what I want. This is a simplify. Let's try to find where my Taylor series went here. Maybe it doesn't really matter that the square root of c squared is in here, just as long as I know how to reproduce the denominator things. So I'm pretty sure that this thing here, b plus 2cw0, that is equal to my, oh, I can just look at this vector and say, we have the 29393, that's the last term. That has a power of 12 here. So the 12 is there and the 29393 is there. Except you get this number. And that is because here I have removed the 2c from it. So I think this factor of 2 gives me that number, right? So if we multiply this with 2, then we get the number that I have. So let me try that. 858 9934 592 times 2 is, yep, that is 171798 something. Yep. And then I have to divide that by 2 to the power 24. And then I get 1024, which is this one. So in effect, I had to multiply it by 2 and then divide it by 2 to the power 24. So I have to divide this by 2 to the power 23. And then we get the number that I want. So we can do more terms and then hope for the best. Okay, so plain text, please. Copy. This is the Lorentz series, but you can hopefully find back that number in it anyway. Yep. And that is then divided by this number. And we have a 24 here. So we now copy this number to my BC and then divide it by 2 to the power 23. Then I get 1024, which is this number. So now we can continue with this series. Continue, oops. Continue here. So I get minus, and then a plus, and then a minus, plus, oops. No, one more, no, that should be enough, hopefully. And this thing is the following. Might as well have added that. 13, 14, 15, 16, 17, 18, 19, 20, 21, 20. That one. So built-in error check. Every other thing must be equal to the previous one. Really every time a factor of 2, right? Can't type anymore. 29. Yep. That is correct. And then the next one is that one, 31. And then we get this one. This must again be that. Could be. Wait a minute. 34. Yep, still the same. This one. By 2 to the power 35. So again, just a factor of 2. Kind of convinced that that repeats. And this one is boring as well, but I'll keep checking it. Yep, again the same thing. And then one more that actually gives some more information. That's this one, and then 39. Okay. So I have the next term is the same as this one, and then double, and again double, and so I need 4 more terms before I get more information. And this was the last one. So we have 1, 2 more, not 4 more. So the rest is not interesting. Or I could ask for even more, but hopefully this is enough. Let me delete this. Okay, do we see the pattern in 2, 2, 8, 8, 16, 16? Maybe I should just copy it. Substitute any number of spaces with a comma. Denominator of the Catalan numbers. Denominator of the Pauli coefficient of the Legendre. Oh my, I don't even understand what that is. Catalan n divided by 2 to the power n. What are the Catalan numbers? Where is my reference to the denominator, sorry, the enumerators of those numbers then? Numerator is in the expansion of 1 over the square root of 1 minus x. But that's not what we are looking for. Wait, what was that? No, it's not on a platter. Let's do some work, I guess. Denominator of the coefficient of x to the power n in the nth Legendre polynomial. The numerators are that's what is not the same. See, my numerators were these 5, 7, 21, 33. And those are just the numerators of the square root of 1 minus x. But then that doesn't fit the denominators. So just starting at 5, 7, 21, 33, 4, 2, 9, 7, 15, 2, 4, 3, 1, 4, 1, 9, 9, 2, 9, 3, 9, 3, 5, 2, 0, 0, 3. Well, that's enough, but one more. I guess. Oh, let me just add the signs as well. It's alternating sign. Yup. Search. Yeah, these are the numerators of the expansion of the square root of 1 plus x. So I have a 1 and a minus 1 in front of it. Well, I have the 5 here, the 1, sorry. Before the 5 comes a minus 1 here. Oh, this is a negative of that. Okay, let's start with that then. So making this a minus. And then this becomes a minus. And then this becomes a plus. And a minus. And 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 a plus. And a minus. Plus and a minus. So now we have minus 5. Could have done that faster, I realize now. But I've done already. Anyways, that's just this series. And then you have a minus 1 and a 1 in front of it, and even 2 more 1s. Yeah, can't do that. But we can do the minus 1 and the 1. And then to verify, I'll do one more. The next one is 334305. Yep. Totally correct. And the problem is that, here's an example. The square root of 1 plus x is this, which then looks very much like what we have, except that it is divided by 2, 8, 1628, 256, 1034, 2048, and so on, which is absolutely nothing to do with what we have. Ugh. Or does it? Because they don't have that factor 2 under the exponentiation. We just try to make the first terms match. Then what should I do with the x? Put this up a bit. It must be minus x squared divided by 8. That means that I have to bring a 2 in the x. I think so. So we would make this one, let's not do that. Copy. Oh. Okay, just kidding. Copy this anyway. Yep. Long. So we make this a 2. Then, of course, I have accidentally multiplied this with 4. So that becomes an 8. And we have multiplied this with 8. So this becomes a 16. We multiplied this with 2 to the power 4. So 8 times 2 to the power 4 is 128. And so on. This is not correct. 1628. This is bloody correct. Is it that easy? Okay, let's continue. 8 times 2 to the power 5. 256. 16 times 2 to the power 6. 1024. 16 times 2 to the power 7. 2048. 128 times 2 to the power 8. 32768. 128 times 2 to the power 9. 65536. 256 times 2 to the power 10. 262 144. And then 256 times 2 to the power 11. 524288, and I don't know what I was doing. 524288. 1024 times 2 to the power 12. That is 4194304. I think this is all the way correct up till where it is given here. This goes to 33, which is 2048. Yep. See here, I don't see the pattern actually. No. But yeah, this must be correct. Maybe a few more just to be 100% sure. 1024 times 2 to the power 13 is a big number. 8388608. No wonder I wanted to get rid of that. 2048 times 2 to the power 14. An even bigger number. 33554432. 2048 times 2 to the power 15 is place 67108864. And 32768 times 2 to the power 16 is 2147483648. Still we have to do this. I don't feel like doing the rest. But you know me, perfectionist, or so to say, autist. 32768 times 2 to the power 17. 4294967296. Oh, if I delete it, I can't even reproduce it at all anymore. Might as well remove all the terms then. I think if it's correct up till here, it's just correct. So I'm gonna delete the rest. Okay, so let's expand. Now let's first check it. The denominator of binomial. Damn it. Give me a square root. Ah, thank God. Square root of 1 plus x equals. Okay, so back to Wolfram Alpha. Taylor series of the square root of 1 plus x, x 12, and then the question is this equal to what we just found, divided by minus divided by 8 plus 15 plus 7 56 minus 21 plus 33 minus that plus that. Totally great, except of course that we're missing a few beginning terms. So if I want to fix this by adding the first term, well, I have to add 1 plus x over 2. So 1 plus Yep, and then we have to subtract it again. Yeah, can't you do that in here? Minus 1 minus x divided by 2. Plus, right? God, this is so messy. Let me for a second go back to this size. I have to move this. What? That should go there, and that should go there. Yes, the minus 1 drops against that, drops away against that, and the minus x divided by 2 drops away against that. So this equals minus b divided by 2c minus c divided by beta times, no, let's make this a plus, and then this becomes a plus 1, and this becomes a plus, and then this becomes a minus. And then this whole thing apparently is the square root of 1 plus x. Interesting that all this effort was for nothing. Holy shit. Aren't they just back at square one now? I'm still dividing by beta here. I have the feeling that this is going nowhere. This is going absolutely nowhere, right? It's just the same thing as we had before. This is gonna drop away against that, and then we end up again with, yeah, the same bloody thing. Shit. The most annoying part is that there's still dividing by beta there. That's what I wanted to get rid of. Yeah, no, all in vain. I don't think we made any progress at all. So if h equals 0, then beta equals 0. Therefore x equals 0. So this is just -1. That drops out against that one. And this is also 0. So the whole thing becomes 0 divided by 0. Yeah, there should be a lot more 0 than that one then, because we need this whole thing to go to 0. It's not more 0. I'm suddenly getting 2c too many. Minus b divided by 2c plus 2c. For beta goes to 0. Okay, anyway, since I ended up here, I might as well attempt that. I want to go somewhere, at least to a formula that looks like this. But then starting from this. So in order to make this 1 plus something, I have to divide by 2c outside of it. Yep, let's divide by 2c above and below. I think that does make some progress. So I have this frac, and I want to divide by 2c. Let's put the 2c in front of this. And then we divide up here also by 2c. And the beta omega 0 divided by 2c. Let's make that a frac as well. I mean frac. Minus the square root of, and then this must be divided by 2c squared, so this becomes 1. And this must be divided by 2c squared. Okay, let's divide it by 4 first. So divide this by 2. And then divide this by 2. And this by 2. And then we have divided by c squared. Now let's do 1c outside it and the other inside it. Where then this better become a frac again. I'm not sure. Frac B. Let's see if that looks correct. We have a frac here, literally. That's no good. There must be backslash in front of it. Okay, I divided this by 2c in here, so this becomes 1, this becomes the same thing divided by 2c, and then here divide by 2c squared under the root, so this becomes 1, and this becomes, oh, does it look very nice? Well, the idea is okay, I guess. This is divided by 2 outside and 2 inside, and then inside also divided by c. And outside by c, so yeah. But it's a miss. Where I really wanted to go to, I think, was 1 plus x, right? Is that not what I wanted? It's basically what you expect here. So that's on the thing on the root should be equal to 1 plus 2 beta times W0 minus W1. Okay, so I'm going to multiply this with 2 here and then divide it again by 2 here. No. Let's keep the 2 beta. I'll do them smaller steps. skip the 2 beta and just simply divide this whole thing by 2c squared. Something went wrong. So better start over. So I'm missing closing brace then. So now I have 3 of them. Frack. Backslash frack. Okay, divide by 2c, this divided by 2c, this divided by 2c squared, 2 beta b plus 2cw divided by 2c squared. So that's correct. But that's not my x. For my x I just had divided by 1 to c. Looks like it. Yeah. Totally. So my x I missed a square there. Yeah, okay, so it doesn't really matter. As long as this is correct then. Okay, let's work that one out. So this is I should have divided by 2c here. It's better divided by 2c, of course. Duh. Then under the square root, I want to work this one out. That is too bad. I frac times something. Let's leave this. Yeah, I want to divide one here inside of it. So let's make this one first. That plus b. And then I'm going to divide this by 2c. And this by 2c. I'll fix it in a minute. And then the square here disappears. And then this becomes minus. And then this becomes minus. And then we'll make this a frac again. Where is my promised minus b divided by 2c? Well, it's in here, but what did you have up front there? Okay, I'll simplify this a little bit more. I'll just take another step. Bit a stupid thing that the more you add, the slower it gets. You see delays when I type, it's just here, local. It's continuously updating that thing. It's very slow apparently. Okay, what did I want to change? It's also very stupid that I cannot see both at the same time. I have to scroll up and down all the time. They should add a scroll bar here that you can just see what the last part that you're typing in real time. Maybe a column here and a column there with two vertical scroll bars. I mean, the live updating, if I change one character here, live updates the whole thing, but I can't see it because it's way down. It makes no sense whatsoever. Might as well not update it until I start scrolling here. Then it wouldn't be this slow. Anyways, so now I want to divide the two away. Replace this with W1 and put this C in front of here. So we get beta divided by C times W0 minus W1. Let's see, so this 2 is removed against this division here. Did I see that correctly? No idea. Yeah, that looks right. And then this holds, so that is minus b divided by 2c. Can be replaced with that. And then the division by c, I want to actually combine with the beta here. So this is divided by c, but no longer. And this is frac beta c. Tja. And this is where you want a substitution, such that this becomes a single variable, which then has its impact on something else, because something has to go. I guess beta. Do I have to replace beta with something? No, gamma, I guess. So then, let's see, if gamma is equal to beta divided by C times W0 minus W1, then beta equals gamma times C divided by W0 minus W1. Feels like there's a factor 2 missing, but yeah. Can't have everything. It's really weird that there's not a 2C here. Feels weird. Guess that because there was a 2 here already. I'll check this with the C++ program in a second, I think. Just let's make one more step and then we can just see graphically if I didn't make a mistake or not. Maybe better if I first do it on paper and then type it in, because otherwise I get crazy. So I have this, so you have 1 plus beta omega 0 divided by 2C. What is the square root of 1 plus beta divided by C? 0 minus omega 1 divided by beta divided by 2C. Replace beta with gamma C divided by that. Then the C drops out here. This whole thing becomes a gamma, of course. Yeah. And this becomes gamma C divided by W0 minus W1 times W0 divided by 2C. So the C drops out and we get a 2 here. Did I do that correctly? Yep, let's just type it in. Can I check it on the screen? Probably correct. There is my thing here. So that then equals a big frac I'm going to divide by another frac. Which exists of gamma. And here I have 2 times W0 minus W1. And then here we have 1 plus frac minus square root. Probably that one. And then this frac is much like that one, I have to admit. Gamma W0 divided by this. And the square root is then 1 plus gamma. Yeah, see if I'll give it that worked. It looks like intended. So the 1 is just the 1. And this thing is the same as that thing, apart from a factor of W0, which was also the case here. And beta divided by 2c, well the 2, let's look at this one. The 2 just stands, and the c cancelled out, because beta equals gamma c divided by W0 minus W1. So looks very good. And then if you fill that in here, beta is gamma c divided by W0 minus W1, then yeah, we just get the gamma. So I think that's correct. Give the thing a tag. Where was I with my tags? I gave up on the idea of tags a long time ago, it seems. I think I saw tag 7. Let's try 8. 7, long time nothing. 8. Yeah, well, suddenly we begin again. It's a new day. Probably should number this one as well. Now, yeah, this factor here is just in order to make clear that this whole thing disappears. Oops, really? Oh, if you select it, you jump back to the top. Nobody knows why. So that, in other words, this beta here should become gamma, I think. Just beta is now replaced with gamma. At the bottom. Gamma. And here as well. Gamma. Yes. So how to turn this into that? Good question. How about yeah, the only thing I really can do is just make the Taylor series or something, because I don't know. It's an approximation for small gamma then, but yeah, not really happy about it. Maybe I don't even want this form. I would like this form if it was a nice form, but it isn't. Hello, Nishkal. My music arch. Desktop and warmer doesn't really matter, I think. And no, it wouldn't work smooth on your PC. It just really is a really CPU sucking thing, this Chrome. If the bug is in Chrome or in of the Math Stack Exchange, I don't know, but continuously updating of loads and loads of mathematical formulas from LaTeX in JavaScript, I bet, is very slow. Or maybe you didn't mean that. I don't know. Anyway. Do I feel up for the next step? Or shall I just go for some exercise, as it were? A stroll outside. Get more energy. Let's see. To connect the tailor rings of this thing, and then the one drops out, and the rest probably completely collapses to this plus gamma times something. But that something is then a series, an infinite sum, which is only converging for small gamma. Yeah. Maybe we should just plot gamma by kappa. I'm gonna try this one out, see what happens. So in the program, okay, we're here, we'll write it, go to the program, backtrack. And we were at this one. I'm gonna change that into, keep this double comma equals beta divided by c times W0 minus W1. And then, yeah. One plus comma W0 divided by 2 times W0 minus W1 minus the square root of 1 plus gamma. That was a minus, and then all of that divided by this thingy. But this thingy is just the same as that, but then without the W0. AKA gamma divided by 2 times that. No. Yeah, and that works. So this vertical line is now drawn at the new formula, and that looks perfectly the minimum of the third degree polynomial. So totally right. So it disappears at the right moment. Everything is good. So did not make any mistake. This formula is correct. Very good. And then yeah, if you really want this, I have to somehow get rid of this, the one here, and I think, I don't know. Well, I mean, if you remove the one against this one, then suddenly you can divide by a gamma. This gamma divides that gamma, and the Taylor series here. Beautiful, as it were. Or not, because if I divide it by gamma once, oh yeah, then we get here something, and that combines with that, and that becomes that then. So we still have a gamma times something. I don't see any other way than expanding this in a Taylor series and then get this, which then gives me kappa as an infinite series. Which we then can plot. Who knows? Does that will give insight or something? I must say this looks very ugly. Why not multiply with 2 times W0 minus W1 above and below? Can put that just in front of the square root. Okay, one more step then. Then 2 times W0 minus W1. Just come up front. Comma. Let's put that there. Let's put it there. Put it there. Let's combine. Sorry. Let me no. What do I? Should go above here. Yeah, I think the whole idea of having this here is nonsense. It just doesn't work. I'm going to write this as, let's see, where is it? This part should go. Let's write this as W0 plus frac times W1 minus W0. Where the frac is then equal to the square root of 1 plus gamma minus 1 divided by gamma. Well, it's as beautiful as I can make it. So if gamma goes to that, which is linearly somehow with h, so if gamma goes to infinity, then this goes to 0, and then we have the 0 at W0, which was correct. And if this whole expression goes to 1, then we have the 0 at the W1. So apparently this expression equals 1 if gamma goes to 0, which is true, because the Taylor expression of this is a 1 plus gamma times something, plus gamma squared times something, what you can ignore. Actually, it is just, wait a minute, that's gamma divided by 2. Yeah, okay, but it drops out. So you get Taylor series is of this is 1 plus gamma divided by 2. So then, no, this is not good. And you get a half. Loss of factor of 2 somewhere. Yeah, what? So we have this term here divided by that, then you just get W0. And I swap these two. So we have square root of 1 plus comma minus 1 instead of 1 minus the square root. And that minus sign is then taken care of by writing W1 minus W0 instead of W0 minus W1. But I still have to divide that part, so this and that, by all of this. And yeah, the factor of 2 is missing. So the gamma is still here. Dividing here by that means multiplying here, but then with the minus sign. And I still have to multiply it with 2 as well. So there must be 2 up front here. Yep. That's better because this Taylor series of this is 1 plus gamma divided by 2 plus stuff. So then the 1 drops out, so you are left with gamma divided by 2. And then divided by gamma multiplied by 2 is 1. And then combine those two and then W equals W1. Yay. It all works out. What did I put in my program then? This one? Not this one, huh? Let's try this one. Yep. Okay, well, whatever. So W0 plus 2 times the square root of 1 plus gamma minus 1 divided by gamma times W1 minus W0. Yep. Yeah, it's still going through the minimum, so dus correct. Het werk. Let's take a break. Let's take a break. Okay, actually, before I take a break, let me understand that now I proved that for certain h values, this 0 lies in between W0 and W1. I mean, if this whole thing goes to 0, it is equal to W1 0, and if the whole thing goes to 1, then it's equal to W1. So I guess that if this term lays between 0 and 1, then we have the 0 between those two things. So you have to prove that it is well, that is easy probably, if it is equal to 1 if h equals 0. And then if h is larger than 0, then this expression must be less than 1, become less than 1. Yep. Now, girl, let's be honest. Add 2 as well. So yeah, that 0 is 1, and if you are less than 0, it goes to infinity. Okay, I'm not kind of done then. I mean, this is it's a rather simple formula compared to what I had before. That was pages and pages long. See if I still have it. The first thing I found was Yeah, something that looked like this. Can't even show it. Probably was reduced in size or something. Yeah, that doesn't work. So you just see a small part of it. This is a screenshot of 2 monitors. Yeah, and I didn't finish here, which is went on. That was my first solution. So much for certain tools. And then didn't give up. And then we arrived at this one. Okay, see if we can just post this, and then everyone has a link, and I'll spend the rest of the day reading it, feeling all fuzzy and happy. How do I do that if I don't have a question? Probably should split it up in a question and then post the answer later. So which point shall I ask my question? I guess before this year. So instead of analysis, I'm making a question. And then I'll copy all of this. Actually cut. And then we do answer our own question. I need some things here. Well, I have no idea. Just algebra, so not existing or what? take Mississippi. I'll just use the calculus. I don't know about the rest. Don't care really. Answer it anyway myself. What is infinity? Well, it can't be int because I tried that. Nothing. Yeah, of course it is inft. Abbreviations. And of course it must work, so it must be plus infinity. Guess you just put a plus in front of it. Now, how to link that? What was gamma beta divided by c times that? Where beta equals six H alpha and alpha was that. And I have to prove that this is larger than 0, basically. Like this can be simplified. At least written differently. That's 1 over W0 minus W1, isn't it? Yeah. So that drops out against this one, and then we get a square, which is always positive. Let me add that to wherever alpha is defined. Okay, this was 2c divided by b plus 2c w0. To the reciprocal, that is yeah, it's just w. It's just 1 divided by w0 minus w1, isn't it? Yeah. W0 minus, yeah. Yeah, okay. Yeah, I don't never know if you have to use when or if. Guess it's not right. In other words, when. Let's make it an if. Good, great. Yeah. Maybe this gives me a bottom limit as well, because now you can see that h compares to the square of the difference between W0 and W1 times C. Say I print this value. Yeah. I mean, gamma is kind of dimensionless, so it's a really nice thing to use to determine the other border, the negative side of it. So I guess I'll just print this. I'll just print gamma. I have gamma already, though not in this beautiful form, I think. Let's print gamma. I have it like that. I do have it like that. Maybe this is even a better form. I'm not sure. Nah, doesn't matter. The value is the same. Let's print it. I'm gonna print out DC notice gamma equals gamma. Really. So indeed, your gamma is negative. You are below that point. Use one door again. Still negative. This is all negative. Here it is 0, exactly on top of it. And then the question is, how negative can I? No, actually, I need a positive value. Whoops. No. Huh? What? Wait a minute. Yeah, okay. As it's below it, then I can basically not say anything, and I just jump to this point. We're trying to find the minimum of this curve, which is going to minus infinity, but it's probably going to do something else again anyway, so just jump there. But if it's like this, yeah, maybe I should just jump to the minimum, which I now can calculate anyway. So we jump here, see that, and then jump there. Probably better than fitting a parabola. It has to be. Before I was like, I think I was setting it at 4/5. So if the thing is like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And my feeling was then that if this is at 4/5 of that, so here, then it's close enough to ignore the minimum and simply continue with this point. And then we see that at that point gamma equals 1.2 something. So I could say, okay, as long as gamma is not larger than 1.2, then we'll just use the point. And if it is larger, then I'm going to jump here and just forget that one or something. It could be like really wrong. Then you don't really want to. Well, that's nonsense, of course. It's not a measure point. Might as well use it. It's kind of dubious though, because it could be complete nonsense, this point. Like complete nonsense. Especially if this minimum is, I say, really deep. Let's say, put this up here. Let's make it very narrow like that. Yeah, maybe not that one. Maybe not that steep, I mean. Yeah, let's put it here. So on the scale of the change from here to there, these are the two measuring points. At this point I thought, well, this point, it looks like a parabola. So let's jump here. No, sorry, it looks like this parabola. So let's jump here. And then instead of dropping 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 10. Hello. Okay, almost 20. We drop, I don't know, fraction of 1. Almost nothing. Which means that probably even the third degree polynomial is nonsense. It's probably more doing something like this, you know. And then, well, there's a random point here, but everything happens here. This is a way wrong guess. And then there is also no reason to jump here. Not really. But yeah, you have to try something. So I could say, I mean, I'm going to jump here and then measure it again. It's like halfway, it seems. Which is what you want for backtracking. You just halve it every time. While if this thing, well, you think it is here, and then you measure this, so I'm setting gamma even to 1.2. Then most of the drop that you expected actually occurred. So then it is either this one or that one or something like that. And then it's not complete nonsense. I mean, it's super unlikely now that that this went down and then up again and then down again and then eventually ended in P1. Well, I don't think that's... I wouldn't throw this one away then, really. So we can just start fitting from P1. Fit another problem, I think. But on the other hand, you could say, yeah, jump there anyway, because even if P1 is very correct and there is only a single minimum, then that minimum is most likely there, more likely there than what you would find with another Prolafit, because this is the best 3rd-degree polynomial fit. Maybe I should just always jump there. But yeah, I said break time, man. This is okay. Quit. And I should get up and stuff. And I want to play chess. I don't know. It's always, why do I always want to play chess before I even get up? I think it's just procrastination. I mean, chess is fun, but let's say I keep playing until I win. And if I win a game, I feel good. And then that tiny little endorphin burst that I'll use to get up. I guess that's basically it. Oh my god, the hole that this guy produced. Okay, well, I want to stop him from playing this pawn, of course. Let's begin with that. Is that even possible? Because, yeah, because he played the other knight. Okay, now we're gonna aim my bishop on it as well. Now you're too late. Gonna put even more pressure on it by exchanging the knight, because the bishop is coming as well eventually. But I'll get rid of this knight again. The white colored bishop is never going to protect that. Okay, and then stop the knight here. I mean, sooner or later I have to do that anyway. Wait a minute, could he push it? No, I just take it. So I expect something like then. I mean, you can't play 2, so he's going to play 1. And then the bishop, and then I put my knight there. I suppose. Ah, thank you. Thank you for the pawn. I don't know, what is this? Doesn't even threaten anything. I'm gonna go back. I do not want to lose that bishop, of course. Why is he attacking it again? Oops, shit, I should have put it here. I should have put a rook here. This is not a problem because it's just another free pawn. Take this as well. I think the guy is going to resign soon and feel very depressed. And then the question is if I can get up, because I don't feel like I won a game. He just gave it away. Like, what the hell? Can take another free pawn. I think he wants to exchange here and then exchange there, and then I don't know what. I think I should just allow that. I'm 2 pawns up. Let's exchange everything. I'm going to castle. Now let's get out of the pin. Still defending this, defending that as well. Why not? Oh, wait a minute. If I go here and he takes that, he can take that back. Now I'm going to kick this bishop. not too happy with it, because now my bishop is yeah, over there. If I get one more time the chance to take this pawn, I'm gonna take it. That's 3 pawns. So he probably puts a rook here. Yep, and then let's kick the knight out. Oh, if I do that, he takes this. Can go here, I suppose. At least threatens on this move. The knight can go here as well. It's also a nice development. Oh, fuck me, I didn't see that one. I'm a point down. God, it's too sad for words, right? I don't know. How do we do that? To promotion and beyond. Yeah, I saw that one coming. I thought I'm gonna put the rook here. Thou shalt not pass. Enter, I mean. Can I promote already? Just a few more moves. I don't know. He's gonna double his rooks. Seriously? Is this guy going to double his rooks? Go here, I take. Don't lose the queen. Not good. How do we defend that? Oh, the knight, of course. Yeah, and then the knight goes... Later, the knight goes there. No. Yeah, this one is not free. I don't want to have my knight pinned. Let's move that pawn. We have a common knight here to defend this square, and then I'm blocking my file. So that makes the promotion harder again. Aha. Nah, I'm gonna go here because he has to move the rook first before this one can come there. And then I have a check and a mate here. As good as, right? Is that not like mate? Looks very made to me. And then with a lot of effort, I'm gonna outside for a walk and stuff. Thank you for hanging out, guys.